All right, polygon angle sum theorem. This tells us how many degrees are in any polygon with any given sides. So n stands for the number of angles or the number of sides. So for a triangle, how many sides do we got? 3. So to use this, you would just plug a 3 in. So you'd say 3 minus 2, which is 1, and then 1 times 180 is 180. So this always works. So for a rectangle, how many sides a rectangle got? 4. So 4 minus 2 is 2, and then 2 times 180 is 360. So any quadrilateral with 4 sides has got 360 degrees in it. So this polygon angle sum theorem, n minus 2 times 180, says if you take the number of sides or the number of angles, that should always match up. So if you take the number of sides or angles, which is n, you subtract 2 from it, and you multiply it by 180, that's going to give you the total number of degrees in that polygon. Okay? Questions on that? And it doesn't have to be a regular polygon. It can just be any polygon. So the sides and angles don't have to match up. They don't have to be congruent, is what that means. So here's an example. It says, what's the sum of the interior angle measure of a decagon? So a decagon's got 10 sides. Did I put this on your note sheet?
1,440. Oh, yeah,
Okay. Did I put this on there? Yeah. So the example right there. So it says, what's the sum of the interior angle measure of a decagon? So a decagon's got 10 sides. So you would just say 10 minus 2, which is 8, and then 8 times 180 and get the 1,440. So it's really simple to use. And you'll use that a lot whenever they start asking you about the measure of one angle. You're going to take all of them, get the total number, and then divide it by how many ever sides you got or how many ever angles you got. Okay? Questions on how to use that formula. So it's real simple. All right. So here's 3 definitions. You probably already know the equilateral. You probably already know the equiangular, but it's worth getting down just in case. So I did put a lot of the definition there because you probably do know it. So equilateral, we know what? Equal sides. That's what lateral means. We know equa means equal. Lateral is talking about the sides. Equa means equal, and then what's angular referring to? The angles. I don't know why this is... not letting me get that. Let me try to fix this for a second. Sorry, that's going to bug me, not letting me grab the pen. There we go. I think... I might have to restart this. Hang on, let me see. Is it mirroring up there what I'm doing? Yeah. Why it's not doing it? I don't know. I'll restart it here in a second. All right. So anyways, lateral means your sides, angles means your angles, and then a regular polygon, it has to be both. So a regular polygon is a polygon that is equilateral and equiangular. So a regular polygon has to be both. So it's important that you make sure that it is both equilateral and equiangular. Now that's important right here in a second for the next formula that you're going to get. Okay, so the last formula that we just looked at, it doesn't have to be a regular polygon. That's going to give you the degree measure of whatever polygon you want to get. Doesn't have to be regular. Okay? But a regular polygon means that everything has to be congruent. Sides and angles. Questions on anything on that slide? Okay? So then you've got this formula right here. The measure of each interior angle of a regular n-gon is. Freeze that right there.